Hello friends, welcome you all. So today's topic is Chomsky Classification of Grammar, and in this video we will see the different types of grammars and their corresponding languages. Now, one computer scientist or you can say mathematician Chomsky classified different types of grammars in four categories, and we will first discuss all these categories and then we will discuss each category in very detail. So first category of this grammar is type 0 grammar. You can call this as unrestricted grammar. Unrestricted grammar. Then second type is there, type 1, or you can also call this context sensitive grammar. Then third class of grammar is type 2, or you can call it context free grammar. And the last and fourth class of the grammar is, according to Chomsky, type 3 grammar, which you can call as regular grammar. So these are four classes of grammar, and all these classes can be used for natural languages as well as for computer languages. All four classes we will discuss one by one. So as you know, friend, there are four tuples in each grammar, and you can define grammar in four tuples. So four tuples: set of variables, set of terminals, set of production rules, and start symbols. So three tuples for are same for each and every grammar. Like set of variables will always be there in each grammar. Set of terminal will always be there in each grammar, and one start symbol will also be there in each grammar. Now the only difference is their production rules. Though, so based on these production rules only, we are discussing all classes of these grammars. So first we are discussing the type 0 grammar, which is also known as unrestricted grammar. So here we will apply some restrictions on types of production or production format. So based on that, we can create different classes of grammar. So first we will see here in type 0 what type of production rules we can have. So here the types of production rules, the format of production rule will be alpha gives beta, where alpha gives beta, where alpha will be replaced by beta, any beta. So now what alpha and beta here? So alpha and beta are any string of grammar symbol. Now grammar symbol means grammar symbols include both variables and terminals. So this alpha and beta may be any string of variable and terminal or any combination of variable and terminal. As the name of this grammar is unrestricted grammar, but still only one restriction is there, that alpha must have at least one variable. So if alpha is having one variable, then the length of alpha will never be 0. The length of alpha will never be 0, or you can say alpha will never be epsilon. Alpha cannot be epsilon. So this is the only restriction in type 0 grammar or unrestricted grammar. Now, what kind of language these type of grammar generate? So these type 0 grammar or unrestricted grammar generates class of language as recursively enumerable languages. So these languages are generated by unrestricted grammar. Now, one more thing. So this is the grammar. Then what type of language it generates? With these generate recursively enumerable languages. Now, some mathematical model must be there to implement all these grammar on computer system. So one mathematical model, which is called as Turing machine, is used to implement unrestricted grammar on computer system. So Turing machine, we will discuss these mathematical models in very much detail in upcoming lectures of this playlist. So now, friends, this is another class of grammar, type 1 grammar, which is also known as context sensitive grammar. So in type 1 grammar, there will be all restrictions applicable of type 0 grammar also. So what we are doing basically, we are applying more and more restrictions on production rules of the grammar, and we are creating the different classes of grammar. So in unrestricted grammar, as you have seen, there is only one restriction, that alpha must have at least one variable. Now we will apply some more constraint on this production rule, and then type 1 or context sensitive grammar will be generated. So what restrictions we are applying in this grammar, i, I will discuss. So the format of production rules in this particular grammar is alpha a beta gives alpha gamma beta, alpha gamma beta. Now what alpha beta and gamma are, and what is a is. So alpha and beta are any string of grammar symbol like variable and terminals, including epsilon. Alpha and beta may be epsilon also. Gamma, again any string of grammar symbol which is non-empty string. That means gamma cannot be epsilon. And one more restriction we have applied here, the length of RHS of any production, length of right hand side of any production will always be greater than or equal to the length of LHS. So this is one more restrictions that we have applied, so that we have created one more class of grammar, that is context sensitive grammar. Now what do you mean by context here? What do you mean by context here? So context means if the meaning of any word is depending on its previous word and afterword, then such languages are known as context sensitive language. Like here, if a is preceded by alpha and followed by beta, then we can replace a with gamma. So this is representing context of a as alpha and beta, and the meaning of a is depending on the string alpha and beta. So this is context sensitive language. Context sensitive language. And if I take example of such languages, then you can use any regional languages, you can use any human languages in here in this category, and all human languages or regional languages comes in this category, because in these languages same word may have different meaning according to the situation in which they are used, or according to the place they are used in. So this type of languages are known as context sensitive languages. Now what type of language these grammar generates? So I have already told you that these generate context sensitive languages. Now, what mathematical model we use to implement such languages in the computer system? So we use here linear bounded automata. So this is the mathematical model that we use to implement context sensitive language in computer system. So linear bounded automata, or in short you can call it as LBA. So friends, this particular model, this particular class of model we will not discuss in this lecture series, because this is again a separate broad area of computer science. So it is used in natural language processing. So as all natural languages are context sensitive language, so this is separate broad area, so where it has separate subject for this. So we will not discuss this particular class of mathematical model in this lecture series. So if I take the example of such languages are all human languages or natural languages, you can say. So I hope it is clear to all of you. Then now we will move to next class. So now the next class of grammar is type 2 grammar or context free grammar. Now, in this, uh, again we will apply some more restrictions on the production rules, and what these restrictions are, I will discuss. So here we can have a gives we can have the production like A gives alpha. A gives alpha, where A is single variable, and alpha may be any string of grammar symbol. Alpha may be any string of grammar symbol. So here we have applied one more restriction, that only one variable in left hand side, and right hand side alpha may be any string of grammar symbols, including epsilon. So this is the type of production in this grammar, and as you can see, it is context free. So here the meaning of any word is not depending on the previous word or after word. So that's why it is called as context free language, and all computer language comes in this category, because in computer languages the meaning of any word is fixed. It is not changing with the time and with the place. So here all computer languages comes in this category. Now, what kind of languages this type of class grammars will generate? So these will generate context free languages. Now, context free languages are examples here, if I can say, computer languages. Now, one more thing, what type of mathematical model we will use to implement these languages on computer system? So for this, we use mathematical model pushdown automata, or in short, you can call it as PDA. This particular mathematical model we will also discuss in upcoming lectures of this lecture series or this playlist. So these are the types of context-free grammar, and all these restrictions are for context-free grammar. Now we will move to next class of grammar, which is type 3. So this is another class of grammar which is called as type 3 or regular grammar. So now, what kind of restrictions in this grammar we have? So here we can have only two types of production, which is A gives A, B, where left hand side is having only one variable, and right hand side also having only one variable and one terminal. Now all production rules will be starting from terminal, and variable will be following that terminal. In that particular expression, so in this B is variable, and one more kind of production is there. A gives small a. A gives small a. So these two kind of production rules are allowed in regular grammar. And if your grammar is generating epsilon, in that case, you can also include a gives epsilon. If the grammar is generating epsilon, or you can say the epsilon is the valid string form for this grammar, then you can also include a gives epsilon. So all these kind of only these kind of productions are allowed in regular grammar. So where left hand side is having only one variable and right hand side is having also only one variable, followed by at the rightmost place in right hand side, and all production right hand side of all production will be starting from terminal. And in case epsilon is valid string form for this grammar, then a gives epsilon you can use as a production. And now if we talk about the languages, what kind of languages these grammar generates, so we call them regular languages. So such type of languages are known as regular languages, and these languages we have already in all previous lectures we have discussed all these languages in very much detail. Now what mathematical model you use to implement these languages on computer system. So finite automata we use there to represent or to implement regular languages on computer system. One more, you can also use regular expression to represent regular languages. So regular expression are again one more way to express to represent all these languages. So friends, now we will see the relation between all classes of grammars. So as unrestricted grammar is accepting all kind of production rules, so it is the bigger set. So if we represent in all these grammars in as a set, so that would be the biggest set. So, recursively enumerable languages, or you can say grammar generated by unrestricted grammar, are the biggest set. Now, as it is the biggest set, now if we apply some restrictions on unrestricted grammar, so we can create one more set there that you can call as context free. So, this is type 0 grammar, type 0 grammar. Then one more type is type 1 grammar. And then if we apply some more restrictions on production rules, then we can have one more class of grammar that you call as type 2 grammar. And if you apply some more restrictions on production rules, you get one more class of grammar, that type 3 grammar. So type 3 grammar is the smallest set. So type 3 grammar is the smallest set, or you can say languages generated by type 3 grammar are the smallest set. So as you know, we can define language as a set of valid strings. So the type 3 in grammar or regular languages are the smallest set. Regular languages are the smallest set. Then type 2 is bigger than regular languages. So these are CFG, context free grammar, or generate language generated by these grammars are CFL, context free language. Context free language. Now another set that is bigger than this, so it is CSG, context sensitive grammar. So now languages generated by are CSL, context sensitive languages. Now the biggest set of this classification is type 0 grammar or unrestricted grammar that are recursively enumerable languages, REL, recursively enumerable languages, or you can say unrestricted grammar, unrestricted grammar. So, unrestricted grammar which generates recursively enumerable languages. So, you can see this is the relation between all these classes of grammar. So, if I represent this in one more form, so like regular languages are subset of context-free languages. Now, context-free languages are subset of context-sensitive languages. Context sensitive languages. Now, all these are subset of recursively enumerable languages. So, this is the relation between all these classes of grammar and their corresponding languages. So, I hope, friends, it is very much clear to all of you. Now, if you have any doubt, then you can always write to me in comments. Thank you. Thank you so much.